And that's something important to remember. It's been established for essential oil. Seed to seal is not to manufacture cars or anything else. We follow the process and guarantee a quality of oil. And that is something that is very unique to us. If you look at other standards, they will look at specific steps. They'll look at cultivation. Organic looks at the way that you cultivate the plant, but it doesn't dictate anything about the way you harvest, distill, or anything like this. But for us, we really need to have something that follows each step. Like I said, organic, I always say when the carrot is ready, you pick it up, you eat it. There's no extra step. But for us, when the helichrysum is ripe, you have to harvest it the right way at the perfect time. You have to distill it the right way, or you cannot say you have a quality oil. And distillation is one of those critical steps, but each step holds equal importance, okay? That means all of the steps right here. Now, distillation is one of the cool steps. Cultivation is as well, but you feel a little bit like a chemist here, and it's a lot of fun. And I'm gonna try and share a little bit the magic that is happening at this facility. Because I know it looks like a warehouse right now, but it is a magical place, trust me. So first, this is first day of distillation school. You're going to learn three things. You're going to learn the three key elements that we control: temperature, pressure, and time. If you come back to school tomorrow, we'll learn 390 different other things that we need to control, but today is just three, okay? Are you ready? All right, so distillation is extracting the essential oil that is in the plant, okay? Very simple. We have a boiler behind this room. That boiler is going to use an energy source. It could be diesel, gas, wood, anything that's going to heat water into steam. It's going to send that steam inside one of those cookers that are behind me. These are where the plants are located. That means that on the farm that you saw yesterday, they will cut the stem, they will cut the flowers, and they'll bring them here, stem and flowers together. With helichrysum, about 50% of the oil is in the stem, 50% is in the flowers, but the constituents are not exactly the same. The constituents that you find in the stems are a bit different than the one in the flower, and so we want to cut both of them together so we can have this diversity brought together in distillation, okay? Lavender, which I'm going to sometimes refer to because it's my heart oil, I have to, has 90% of the oil in the flowers, 10% in the stem. So even so, we still cut the stem and the flowers because even there's only 10% in the stem, different constituents, different oil. But we cut the plant whole, we will bring it here, we'll load it into one of those cookers. We have a 6,000 liter one here, 4,500 liter one behind me. We can pick one, we can fill it up all the way to the top with plants, close it down. The steam that's produced inside of the boiler will go through the plant, extract the essential oil, will cool everything back down. And we'll be left with two things. One, at the bottom is the water that was the steam to extract the oil, and floating on top is our essential oil. Okay? Can you smell a little? I don't. Yes. It's not strong yet, but can you smell the plant that is being distilled? Yeah. What is it? I was sure you're going to say helichrysum. Like, I'm waiting to correct, but no, it's sage, yeah. So inside of our cookers right now, we have sage that has been dried from the farm and that is being distilled. Okay? Okay, so did everybody understand the easy way to understand distillation? Right, let's go in the very complicated way. Just for no, it's not that complicated. First of all, any questions? And I explain it the easy way because I'm going to have a ton of questions for you during the hard way, just to try and see if you can take parts of the easy way to figure out the hard way. Okay? Are you ready?
Yep.
All right. So, the idea of distillation is that we want to extract a liquid essential oil that is present in the plant and just obtain it. Now, the oil inside the plant is located in little pockets, like little closed pockets. You you have the liquid essential oil in those little pockets that are closed. If you cut helichrysum or lavender and you let it dry in the sun, what's going to happen is that the moisture, the humidity in the plant is going to evaporate. But the essential oil itself, being in little pockets, is not. As long as you don't break those pockets, the oil is trapped inside the plant. I don't know if it's trapped, but it can't go away from that plant. It stays with the plant. That means that if you take a bouquet of lavender and you put it on the table, and it's dry flowers, and you leave it for a year, if you pick it up, it might not smell like anything. But if you crush the flowers, all of a sudden the smell comes back. Because as you crush, you break the pockets and you release the oil. And so what we're trying to achieve is very simple. We want to break the pockets and obtain the liquid essential oil. So technically we could take the plant and just press it like this. Actually, we do this on certain oils, the citruses. Cold pressed means that we take the peel of the citruses and we press it. That breaks those pockets and release the oil. So that is feasible, and that's what we do on all of our citruses. But for those plants like helichrysum or lavender, there is so little essential oil that it wouldn't really work. And we would extract maybe other constituents as well. Actually, if you take citrus, have you ever squeezed citrus? Yeah, that I do. But that's breaking the pockets and releasing the oil right there. So you see, it's a very, very, I would say, important things that kids are doing. They're learning everything about citrus essential oil and stuff. So we could technically squeeze the plant, break the pockets, and obtain the oil, but there's not enough oil in those flowers and those plants that we're distilling. And you know, a lot of the farms that we have, for example, in the US, distill wood. It's very hard to squeeze wood and obtain the oil. So there needs to be another method. And so do you have any ideas? First of all, let's start there. What could we do to break those pockets and extract that oil without pressing it? Pressure?
Temperature and liquid.
Why would temperature? It's interesting, but why?
Liquid those plants and give temperature to extract those pulp.
So temperature is interesting. You're not far away. Not bad. An idea that we could do would be to transform this liquid essential oil into a vapor. The same as liquid water goes to steam. Steam takes about 1,000 times more space than water. Okay? If it takes more space, it means that inside of a closed pocket, it's going to build up the pressure. So if we vaporize the essential oil, if we take an oil from a liquid oil and build it into a vapor, it's going to increase the pressure inside the pockets, and it's going to break those pockets and release itself. Okay? All following? Are you sure?
Yeah.
How do you go from a liquid to a vapor? Temperature. How do you go from water to steam? You heat it, right? So the boiling point of water is 100 degrees. The boiling point of lavender essential oil, no. So that means that in order to go from water to a steam, you want to be at 100 degrees Celsius. Now, that means that inside those chambers, if we were to heat the plant at a certain temperature, the boiling point of the oil, we would vaporize that oil. But that is problematic because the boiling point of our essential oils are much higher than water. They're about 180, 200 degrees Celsius. So that means that if I had the plant inside one of these containers and I put a fire underneath and I would heat the inside of the container just like you would with water, you would heat the inside of the container. In order for the oil to go from a liquid to a vapor to break those pockets and extract, you would need to be at 180, 200 degrees inside this chamber. That would extract the oil, but it would really be a bad quality oil. That temperature would be way too high. You'd destroy a lot of different molecules, alterate them, and you would not obtain a quality essential oil. Okay? So it's a great idea, but it doesn't work yet. We need to figure out, which is the second question today, how do we vaporize the essential oil at a lower temperature than the boiling point of that essential oil? See, very simple question. Any idea? Come on, you're all a little bit curious in your mind.
Pressure, no?
Yeah, pressure
You have to put
cooking.
pressure.
Pressure cooking, I like the idea. It would be the opposite. It would be vacuum. Pressure would mean that we would need to heat more to be at boiling point. Vacuum would mean that we could technically reduce the boiling point. The same as you boiling water at altitude is that it boils at a lower temperature. You can boil water at 80 degrees in the mountains, and at sea level you need to be at 100. So technically, in one of those chambers, if we were to build a vacuum, we would reduce the boiling point of those essential oils. That would work. Smart. You see? Chemist. But that's very complex to do. It demands very specific equipment that could be very dangerous to build a vacuum on such large scale. Still a great idea. I'm not like vacuum distillation is something that is utilized for multiple things around the world, mostly smaller units, but for many reasons it's used. But at this scale, we want something simpler, I will say. So great idea, not well, I wouldn't say that. I like great ideas though. I want to be positive today. Any other idea? I gave you a lot of little clues during this simple explanation. There's one major thing that you're hearing right now that should be a major clue as to what we do.
You just put the vapor, no, with pressure, with a certain temperature, and you leave it for a certain time.
Don't go too quick. You just said you just put vapor. We have steam distillation, right? We don't send steam because it's nice. There's a reason. Steam is critical into extracting this oil. And let me explain to you why. And I'll do so in a cooking lesson. Is that okay? I'm French, so. Once again, I go to lavender and I go to cooking. I actually didn't eat this morning, so. Have you all fried anything in your life? Not very animated. Are you awake? How many of you fried anything in your life? No.
Yes.
Wow. So you all know how to fry. So if I ask you a simple question, you'll have a simple answer, right? All right, so cooking lesson. We take a pan, we fill it with vegetable oil, we turn on the heat, we bring that vegetable oil, you can choose the one if you prefer coconut, whatever. If you put on the heat, we can bring that temperature of 180 degrees, which is a normal frying temperature. I'm not trying to lie to you, don't worry. So we have a pan full of vegetable oil at 180 degrees. There's nothing in the oil yet. What does the oil do? It boils. It expands a little bit. You've all fried before, but you don't really look at what's happening. Do you fry while watching television?
If you leave it too much, it starts to be burned.
No.
The vapor comes out.
Vapor comes out in bubbles. Okay. So you've never fried anything. At 180 degrees, if there's nothing in that oil, nothing happens. The oil is hot, it doesn't boil, no vapor, and no smell. You can try it at home, I promise. You'll notice that nothing happened. That oil is perfectly still. And that's because the boiling point of vegetable oil, no matter which one, is far, far greater, like 300 degrees Celsius. That means that if you were to heat that oil all the way to 300 degrees Celsius, it'll start boiling and vaporize and go everywhere, okay? Don't do it. Please don't do it. Very dangerous. So, something happens when you introduce food inside of that oil. When you bring food inside of that oil, bubbles, vapor, smell, everything starts to happen. It's because when you introduce food, you introduce water. And what does water do at 180 degrees? It boils, it vaporizes. Okay? So it bubbles because the water goes poof goes away. But something else is happening, and that's going to explain why I'm having a cooking lesson right now. When the water vaporizes, if it's in contact with the oil, it's going to vaporize the oil. And that's a rule. If any vapor or any liquid vaporizes and is in contact with another liquid, follow me on this, whatever the boiling point of that other liquid, it's going to vaporize it. Mm-hmm. That means that when you put water, even though the oil was perfectly still, when you put water, the water goes poof, and the oil it's in contact with goes poof, and you've built a beautiful frying diffuser for your house. And all of that beautiful smell and oil goes everywhere on your walls and just infuses everything. But what you've done is you actually used water to vaporize a liquid that demanded a much, much higher temperature to be vaporized, and you were able to vaporize it. Do you see where I'm going with this? Yes. You sure? So, if we come back to distillation, if I send steam inside of this chamber where my plant is, steam is around 100, 110 degrees. When it touches that oil, poof, it vaporizes, breaks those pockets, steam continues its way, extracting our essential oil. And what I've just achieved is I've vaporized my essential oil at a much lower temperature, not harming them, not damaging any of the molecules. So I've done something kind of cool. See, cooking is fun. So this is what's happening. So this is temperature. Yeah? All right, 2 more to go. Actually, no. Pressure is easy. Pressure would mean we would need to be at a higher temperature to be in the form of a vapor. We don't want any pressure. Technically in life, we all have pressure. We'd rather not have it. It's the same for them. They'd rather not have any pressure. So we don't want pressure inside. We don't need any more pressure. I think you can all agree. Maybe. Anyways, so temperature and pressure are done, right? You need to tell me if you're lost. Be honest. No. At the end of this day, you're supposed to be able to run this facility. So be honest. Like for the safety of everyone in this facility, please be honest. Now is time, and time is very, very important as well. Now, as the steam goes through the plant, it doesn't extract everything all of a sudden. It's not an instant process. It doesn't just vaporize everything and we get all the oil in 2 minutes and we're done. It takes a certain amount of time. And the time is dependent on the distillery and on the plant. Each plant is different. To distill woods, it would be much, much longer because the steam has to go through that wood in order to come in contact with the oil and vaporize and extract it. So it will be much longer to distill a wood than a tiny little flower like helichrysum. And even, Chris helped establish the farm in Ecuador, and a lot of the plants that they do there also have very specific distillation times, and they studied that. But he'll talk more about that later because all of those steps are what makes the quality and the understanding of the quality, which comes back to the rules that we have in Seed to Seal that are so important. Anyway, so time. As this steam goes through, the first thing that it starts extracting is actually the lightest molecule. Okay? So an essential oil is composed of a huge variety of molecules. Some are lighter, some are heavier. The steam is kind of lazy and it goes, I'll pick the lighter ones first. And as it goes through, it'll pick heavier and heavier molecules to extract, all right? But actually what happens, which is interesting, is the first half of distillation. Here for helichrysum, it'll be 1 hour 45 minutes, 1 hour and a half, 1 hour 45 minutes to distill the helichrysum. At our farm in France, the lavender would be 1 hour with the updated distillery. The distillery we had before would be 1 hour and a half. So that's to show you that each plant is different, each distillery is different, and our goal is very simple. Extract all of the essential oil, all of the molecules from that plant. So our goal is very simple, but we need to study and understand what does it take. So in the first half of distillation, most oils you will extract 80% of the oil. The first half, so in France, the first half hour, or here the first 45 minutes for helichrysum, you'll have 80% of the essential oil extracted. And that's because of the different weight and molecules. So, I have a very hard question for all of you again. What weighs the most, a kilo of feather or a kilo of rock?
Kilo is a
It's
kilo.
the same. I'm wishing for
Didn't
some
trick anybody.
No, never. I've never tricked anybody on this. But the steam is capable of carrying a certain weight, okay? And so if the steam starts with the lightest molecules, that means the steam starts with the feather. But the steam can carry a kilo at a time, okay? So even if it can carry a kilo of feather or a kilo of rocks, it'll still carry a kilo, but the difference is that the feathers take a lot more space, right? So they're lighter, but they take up more space. So you have more volume of essential oil coming out in the first half because it's carrying out feathers. And as we go towards the end of distillation, you have rocks, which you carry less of, but carry the same weight, yeah? Actually, there's a lot of things you can notice this way. I remember in Ecuador on Ocotea, you could really see that there was different molecules coming out, because first the oil was really transparent and light in color, and as the distillation continued, you could really see the oil change color with heavier molecules that have a darker color coming out, changing completely the color of that oil.
Your aroma will change as well. Your aroma will change as well through that distillation.
But it takes a certain amount of time, and we need to understand what does it take to extract all of the molecules. But let's say you're a farmer, and your clients are only interested in pricing. Distillation uses a lot of energy, costs a lot of money. You get 80% of your essential oil in the first half, which you would call the entirety of the distillation for yourself, because you say, why would I keep distilling for another half, for another 45 minutes to get 20%? No, that's going to add too much to the cost. My clients only care about pricing, so I'm going to stop halfway, which you would once again not call halfway, you would call, I'm going to stop here, and that way it costs less. Now the issue with that is that you're missing 20% of the oil, but what are you really missing? Quality and the heavy molecules. And so we need to make sure that there's rules that states, no, we need to extract all of the molecules. And the only way we have something like this is if we have a quality commitment that follows every step and dictates those things. That is tailor-made specifically not to manufacture cars, but essential oils. Yeah? That's why we have
Do you know what we call that kind of distillation? Good enough distillation. It's good enough, yeah.
Good enough. No, but so you did pass day one, all right? Are you okay?
Yeah.
Have you survived? Nobody's traumatized?
Taigi, dar lietuviškai pakartosiu, kas yra svarbiausia turbūt distiliacijos procese, nes dabar mes esame distiliatorinėje, kompanijos distiliatorinėje, kur distiliuojami ir šlamutis, ir kadagys, ir seič, šalavijas. Bet esmė yra kokia? Esmė yra, kad šituose talpose augalas yra neišverdamas kaip alembike arba įprastų būdų distiliuojamas augalas, o išgaunama iš augalo jo gyva molekulė. Va tame yra esmė. Dėl to yra labai svarbi temperatūra, tai yra, kad būtų nevirimo temperatūra, čia yra vaporizing su žodžiu išgaunami neverdant, ne aukštoj temperatūroj, o būtent distiliuojame garais. Augalai, žaliava yra distiliuojama garais. Kitas dalykas yra labai svarbi temperatūra, nes būtent pirmiausiai, pavyzdžiui, lavandos per pusę valandos atiduoda 80% eterinio aliejaus, tai yra lengvoji molekulė, o kitas tiek pat distiliuotas augalas atiduoda sunkiąją molekulę, nors tai yra tik 20%, bet esmė ta, kad tame 20% ir yra esmė, tai yra tos veikliosios medžiagos, kurios reikalingos mums, žmonėms. Tai va, daugiau apie tai seminaruose, o dabar va trumpas dar reportažas, kaip atrodo distiliatorinė, kur Kroatijoje.